Good morning, good afternoon, or good evening, wherever you may happen to be, and welcome to the Nautel Fall webinar series. This is number 1 of 3. We'll be talking about MDCL today. I'm Jeff Welton. I'll be your host. Chris Alexander was going to be co-hosting with us. Unfortunately, Chris had a personal emergency and had to drop out. He did, in typical Chris Alexander fashion, send me a list of the things he thought we really should cover. So those will be incorporated in various points as we go forward. So we are talking about MDCL, Modulation Dependent Carrier Level, and we're going to talk about what it is, why we do it, how do we get it. It's pretty basic. The cool thing about it, and we'll hit a couple of housekeeping things first, actually, but if you look at the right side of your screen, there's a control panel there. If you have any questions, just type them in there as you go, and I will answer them as they come up. If we do run out of time for any reason, or there's something where I'm going to need to look something up because I don't promise to know everything, then certainly you will get a response via email. So by all means, ask your questions. We'll make it as interactive as we can. If you're an SBE member, remember that or an SBE member, yes, then remember that completing this webinar gives you half a credit toward research. So that's under category I of the recertification schedule. So that's a good thing too. All right, with that said, let's carry on. So the forms of MDCL, dynamic carrier control, whatever you want to call it, have been around for a couple of decades. Ham radio has used it for years and years. Europe has been using it in AM broadcast, not so much anymore as they slowly shut the AMs down over there, but since the late 90s. And we did a paper on it in NAB in 2009. Around about 2010, Alaska Public Radio got experimental permission from the FCC to run MDCL. And you need to remember that in Alaska, commercial power, where it's available, is frequently as high as 40–45 cents a kilowatt hour. In a lot of places, it's generated. They don't even have the option of buying commercial power, so that's even more expensive. So for them, anything that will drop the power bill 20, 30, 40% is a really, really big deal. In 2011, the FCC issued a public notice approving MDCL and leaving it up to the broadcasters which specific algorithm they chose, and we'll talk about the algorithms in a bit. At the time, and I don't believe anything's changed since, Gates Air and Nautel were the two specific broadcasters approved for operating MDCL. Now, since then, a bunch of folks have installed it, and we'll do 1 or 2 case studies. As I said, Chris Alexander, Director of Engineering for Crawford Broadcasting, was going to co-host, and Chris has put MDCL on just about all of Crawford's AM stations, and they've got around about, somewhere around 10 or 11 stations, give or take, throughout the US. So we'll talk about some of the results they've seen too. Okay, we do have a little glossary because, as you will see as we go forward, there are a lot of acronyms here. So MDCL, Modulation Dependent Carrier Level, method of controlling output power by virtue of the modulation depth. Effectively, it's intentional carrier shift. Okay, AMC is one of the types of MDCL. It's amplitude modulation companding. There's DAM and DCC. Okay, I'm not going to read what's on the screen. Y'all can read just fine. Anybody who wants to view this later, it will be archived, and you'll be able to see it later on by clicking the webinars link on our website under resources, I believe. Okay, so, and again, like I say, any questions, ask them as we go. So the theory behind it is that when you look at an AM signal, all of your information is in the sidebands. But if you look at the total transmitted power, 2/3 of it is the carrier, which contains no information at all. It's just there to lock a receiver in. So MDCL looks at the mod depth, adjusts the carrier level and the audio level to maintain that mod depth so that it reduces the peak power level. And we'll show later on an example of exactly what kind of difference you could expect to see in power consumption. Now, this is a big deal for a couple of reasons, and we'll talk about those as we get going too. So the modes of operation. The DCC is rarely used. What it does is your modulations at low levels, near 0%, it increases the carrier a little, decreases it, well, it decreases a little from 100%, but increased relative to what you see in the mid-range of modulation. And as you hit heavy modulation, higher peak amplitude levels, it starts to increase the carrier again. The theory is that it gives you a little bit of a boost at the ends, and in the middle, when you've got a lot of audio content, it tends to reduce a little bit. Very few people, I'm not aware of anybody using this one at this point. What you'll see mostly in the States is AMC, and I have seen DAM in some other places. Now, speaking of DAM, here it is. And for it, it reduces the power level when the modulation is low and increases it when the modulation's high. The advantage is that at higher modulation levels, you get even higher peak levels, so theoretically a little bit greater range. The downside is that at lower modulation depth, when you're decreasing power, you're going to decrease range significantly. Thus, overall, you are going to have an impact on the signal to noise, especially on the fringes at the edge of your coverage area. So again, in our markets here, where we try to cover as much as we can geographically, that's less of a valuable situation, although it does show a significant decrease in power overall. Okay, full DAM is a little bit of a compromise. So it starts high, goes low, goes high again. And you can see what we're looking at is power and peak voltage relative to modulation depth. Okay, so that will vary a little bit from one algorithm to the other. And ultimately, you pick the one that is going to fit your specific style of modulation and your specific coverage area. If you've got a situation where you're covering a town and there's absolutely nothing outside that town, then one of these may be a better solution with more savings than, for example, one that has less impact on the fringe, but also less savings. AMC is the most popular, and what's shown here is AMC 3 dB, so 3 dB of compression. And what you can see at 100% mod, the power is reduced to half, or 3 dB. Now, there's various levels. You can set the compression 3, 4, 5, or 6 dB. Now, 6 dB at full power, or full modulation at 100% mod, you'd be at a quarter power. The advantage to AMC is that at 0 mod, that when it's carrier only, it goes to 100%. And we'll talk about that in a little bit. Chris had mentioned a point about why they specifically use AMC with 3 dB of compression at Crawford. Then there's enhanced AMC, EAMC. And what you'll notice is that all of the other scales, I'm going to click back a little, all of the other scales go to 100%. This one goes to 200%. The reason for that is because enhanced AMC, in addition to reducing power as modulation depth increases, at lower modulation depths, it has a boost function. So you can increase power. So for example, if we look at a 1 kilowatt transmitter, at 0 mod, it'd be putting out 1.5 kilowatts of carrier. So it increases the carrier as the mod goes down, and you can see that the crossover is about the 70% point. Now, that's useful because over and above the ability to reduce the power bill, and obviously if we're increasing power at the lower mod depths, it's not going to reduce the power bill as much as traditional AMC would, but it is increasing your peak voltage. So you're seeing, or peak power rather, so you're seeing a noticeable increase in range. Okay, this one would have the least impact on signal to noise, if not actually improving it. So something else to consider. As I said, it's situational. You will look at your specific scenario, and that will be what decides which algorithm is best for you. Now, some feedback. This is direct quotes from Chris Alexander talking about when they first put on MDCL at their very first 50 kilowatt station. And you can see that they're talking, and they're running the most conservative level, AMC with 3 dB. And you can see that they saw a 21% reduction. And other folks have seen 24, 25%. It will vary based on a lot of things. And you'll also notice that they're saying that empirically, at least with listener tests, that they're not seeing any difference. Now, obviously, if you go out there with a field strength meter, you're going to see a lower signal level at some point, but they're not seeing any issues. Now, I don't know about the latter before, perhaps that's perceptual. Either way, it's not showing any negative effects. So this is Amanda Hopp. She's the director, chief engineer for Crawford's Denver stations. And one of the things she mentions is that because we reduce the peak power, especially in systems where you've got older equipment, you know, aging ATUs or whatever, this will tend to put less stress on those components, because less peak power means less voltage, means less stress on older components. So for somebody with some stuff that's not shiny and new, it could potentially help to increase the lifespan overall. Same goes true of the transmitter. The transmitter's drawing less power. The breakers in the panel are handling less current. Overall, it's just less stress on everything. Of course, then again, you turn the power down, same deal. So here are Chris's specific observations. Number one, and this is why they used AMC, because as we mentioned before, AMC gives a boost at the lower end. So when there's no mod, you're up to full power, and the power is reduced as you increase the mod depth or the peak output. The reason they chose that is to keep the AGC active in the receivers, so that the AGC, when you're at low mod, doesn't increase gain and increase the amplification of any atmospheric noise. So that was one big reason for using AMC, just to minimize the noise on the fringe. He did mention that their listening tests showed no perceived impact, and again, measured and what you can hear on a receiver are not the same thing. But we all know that the difference between 10 kilowatts of power and 5 kilowatts of power is measured in hundreds of feet, not in miles. So, you know, if you drop your power 3 dB, other than the perceptual difference, because you know it's half power, it's not really going to make that much difference overall, except on your power bill. So if we can do that in such a way that it does this without impacting your license, so you still get your fringe protection as far as the neighbors go, then that's not a bad thing. Okay, so they're 50 kilowatt stations, and Crawford has got 1, 2, 3, 4, 5 that I can think of. They're typically saving $1,000 to $1,500 a month. So anywhere between $12,000 and $18,000 a year. This is US dollars for reference. In the US, power on average across the country is 12 cents a kilowatt hour in the continental US. So you can do the math there. Now, one thing Chris did note was adding LED lighting to their towers also made an improvement, obviously. And if you have an area with demand billing, which for most of us with transmitter sites is all sites, running your aux transmitter can totally obliterate your MDCL savings for that month, because you go into the next demand level, and at that point, your whole month is billed at that rate. I've heard of a few areas where the demand billing is annual. So if you kick into the next demand level, that's your bill for the whole year. So really, really, really be careful about anything that could kick you up into the next demand level. I've been in sites, and obviously for this reason, where the only way they'll run the aux transmitter and the main at the same time is on generator. Now, the other thing to remember is if your aux transmitter doesn't have MDCL and you have to run it, then you could potentially be into the next demand level as well. So if you're in a situation where your main is off for maintenance or for cleaning or whatever, and you're running the aux, you may want to consider reducing power on the aux just to keep yourself from going up the demand level. Okay. One other note is that MDCL overall requires less generator. So typical 50 kilowatt with 125% modulation is going to draw, on the average, about 80 to 90 kilowatts of power. Time you add tower lights, air conditioning, 120 watt loads, 100 to 120 kilowatt generator is pretty common, and that's not got a lot of headroom on it. So what Chris is saying is their KBRT 50 kilowatt in California is running a 70 kilowatt generator, including lights, air conditioning, and all the loads, including the transmitter at 50 kilowatts with AMC II MDCL. So that's a significant difference. I mean, a 70 kilowatt generator versus a 120 odd kilowatt generator is a big difference in cost. It's a big difference in fuel consumption. So yeah, it's definitely something that you want to keep an eye on and pay attention to, because that's not insignificant. Okay, so the specifics. If you're in the US, you need a waiver of 731560. Okay, because like I said, this is intentional carrier shift. It does, you do need the waiver of that specific rule. Now in Canada, I think you need to get an experimental license. I had one guy telling me that they got MDCL turned on recently, but they had to fight with Industry Canada, or whatever they called this year, for quite a while to get that. So make it a point to make sure you talk to the regulator in your specific country before you just turn this on. This may be something that requires special permission, whether it's an experimental license, whether in the case of the US, it's just a waiver, or whether it's something that the regulating authority may decide to change their rules and just allow out of hand. So it is something to be aware of. The other thing is that the different algorithms will have an impact on audio quality and or coverage area, you know, or on signal to noise at the fringe, which is, again, audio quality. So once you decide what you think you want, try it out, try some of the other ones, and see which one fits best. The other thing to remember is there are, in our case, 5 algorithms available that you can select. And some of those algorithms, like AMC and EAMC, will have various things that you can adjust. Either the AMC ones or the EAMC, you can adjust the amount of compression, 3 dB, 4 dB, 5 dB, or 6. On enhanced AMC, EAMC, you can also adjust the gain that you see at low-level modulation. So maybe you don't want to kick it up 150% at 0 mod. Maybe you want to kick it up at a lower level. Now that's done in decibels, so you'll have to do the math. For example, 150% power is 1.76 dB. But so you've got some variables there, and that way you can tailor it, sort of like, how you set up a processor and it takes a little while to get it the way you want it to work, the way that you want the sound to be. Well, it's the same thing here. You let it, or get it, and then you tweak it until it's performing exactly the way you want. Anybody who set up AM stereo remembers the compromises we used to have to do between day pattern and night pattern, even on the stereo generators that had the way to adjust for both. You tended to pick what worked well on one and then go to the other and set it up as well as you could, and then go back and fix it, then switch back and forth till you've got the best compromise. And that's how this is. You're looking at power bill, you're looking at coverage, you're looking at audio quality, and you're trying to do, the most improvement to the power bill and the least damage to everything else. Now, the other advantage to this, though, of course, if you're just anymore, and I hesitate to say it, but it's probably got to be said, if you're using your AM station anymore just to drive translators, crank the MDCL up all the way, drop the power bill as far as you can. But again, that's totally dependent on your specific situation. Okay, so on some, and it will vary, I can only tell you how to implement MDCL, of course, on Nautel transmitters. I can tell you that on the Gates Air transmitters, the DX series and the DAX series, I believe, but I know for sure the DX series, you can implement it. Beyond that, I don't know. You're going to have to talk to your specific manufacturer. On our NX series, you go into the preset menu, go into the analog settings, and you tell it, yes, I want MDCL, and just tell it which version. Now, we call it dynamic carrier control, which goes back to the days that predated MDCL. But whatever name you want to call it, doesn't matter. You go in, you select your algorithm, you save your preset, you activate it, and you're rolling. Now, I see a question here from Marco. I'm just going to see if I can get to this real quick. I think it's from Marco. There we go. In Canada, okay. So Marco says he just had to send a letter to ISED, what used to be Industry Canada, that they were running MDCL. So somewhat similar to the States, where you send them a letter to request a waiver for 73-1560, the rule related to carrier power. So good. Thank you, Marco. That's useful information. So if you're in Canada, it's just a letter to ISED to let them know you're running the MDCL. Okay. So again, on the NX, it's easy to set. You select your options. Now, when you select, for example, AMC mode or EAMC, it will ask you for the level of compression. And in EAMC, it will ask you for the level of boost. And you may choose 0 or whatever. You pick whatever you want. Okay. If you're running AM IBOC or HD radio on AM with our ND, XL, and XR, then it's just a firmware upgrade. So it's pretty basic. The software's there. For the people that want to know, and I haven't seen the question yet, but I'm sure it's coming, you can run HD radio and MDCL together. Now, if you're looking forward to MA3, all digital radio, remember that your HD carriers on AM are phase modulated onto your analog carrier. So in an all digital world, MDCL wouldn't gain you anything because there's no peak variation. Okay, so that's just something to keep in the back of your mind. But for analog, hybrid, analog use or hybrid HD plus AM, then MDCL certainly does work well. Okay. Now, if you're running an XR series, the older transmitters, and it's not running AM IBOC, you'll need an external DCC unit. It's the funny thing is that there's a lot, because we're changing phase and amplitude, I and Q, the upgrades on older gear that you need to do for IBOC are about the same as the upgrades you need to do for MDCL. And that's where we get into this part for older transmitters. You do need to do some changes. The support department can quote you on that. The cool thing about it is, and we'll get to that in a little bit, but overall, the cost of an MDCL upgrade, even for an older box where it's significantly more, and you may make a decision to go with the new one, that's up to you, but the cost will be recovered in the power bill in fairly short order. We're talking a couple of years typically. And we will see some examples of that in a couple of minutes. All right, now moving forward. This is an example of a actual measured power, okay? This is at a test that was done fairly recently, and there was just a power monitor on the line, transmitter running kilowatt and change, and you can see the differences between, in this case we were looking at AMC and EAMC, but you can see the differences in peak power consumption. In 15-minute increments we switched modes, and you'll notice like AMC 3 dB, even with higher modulation, is a significant decrease in power consumption. So that is something else that's really useful, okay? And that's something that we really do need to pay attention to. All right, I've got undocked questions. Okay, John has asked if there's any advantage of MDCL on a 1 kilowatt transmitter, and we're going to show you that in a couple of seconds. I will flip over to the calculator on our website, and that way you can do, because again, it's going to vary. I can't answer the question because until I know, you know, if you're in Alaska at 45 cents per kilowatt hour, then yeah, there's an advantage to it. If you're in, well, in Georgia or the deep south where I happen to be at the moment, then power runs 7 to 8 cents a kilowatt hour. There's a lot less benefit to it. You know, so at that point, I don't know if it would be cost effective on a 1 kilowatt, probably about 5 or 10 kilowatts would be the break even point. You know, again, though, remember the other advantages. It does reduce peak power, so it reduces stress on your ATU, it reduces stress on your electrical infrastructure. So there is some benefits there as well. Okay, now, and remember, as we'd expect, of course, I've got a laser pointer in my hand and you can't see it when I'm waving it at the screen, but the difference between AMC and enhanced or EAMC is minimal. Because as you, well, no, it's not minimal. You have less savings with EAMC because you're boosting at lower mod depths. So that is something else to be aware of. Okay, John Cooper also wants to know if MDCL can run as AES EBU or does it specifically need to run as analog audio? And the short answer is it doesn't matter. In the particular test that this graph is based on, we were running AES audio at one point. At one point, we were running just standard analog. So no, it makes zero difference what format your audio's in. This, of course, assumes that your transmitter will handle AES EBU audio, and I guess the NXs all do. So I'm happy with that. But yeah, absolutely, it does. It makes no difference whether you're running AES or whether you're running left-right or left plus right or whatever you happen to run. Okay, now carrying on. So what I was saying, and this goes back to the question about whether we could do it on a 1 kilowatt. The website, our website, has a calculator. And you can enter data in there, your average cost per kilowatt hour, the power of your transmitter, nominal efficiency, and where this comes useful, it's not just for MDCL calculations, although that's an obvious benefit, but you'll see right here, I happen to have in this example 55%. I picked an RCA or tube transmitter. And so we look at a 10 kilowatt tube transmitter. and the hours of operation. And we can tell you that without MDCL, we'll save at that power rate at 12 cents a kilowatt hour, again, looking at the average for the US, that we'll save about $11,000 a year. We turn the MDCL on, and this was looking, and remember that we kind of picked an average here. We picked 30%, which is a little more than you'd expect from AMC III, but a lot less than you'd expect from AMC 5 or 6 or EAMC 6 or some of the others. And if we go back to our little graph or chart, see, I'm going to have to, there we go, click a button and go back. So you can see that we hit the 30% mark on average savings pretty early on. AMC 4, EAMC, you're down to the higher levels before you get there, but it is quite achievable. So with that parameter, your savings, just replacing your tube transmitter, the regular transmitter, are significant. But if you go up to adding the MDCL, your savings go up about another 50% in relation. So we're not talking small savings here. I mean, when you're looking at $17,000 a year, it doesn't take a whole lot to pay the purchase price of a new box. You know, so for the 10 kilowatt level at that power rate, it'd be a really good deal, especially if you happen to have a tube transmitter that you're looking at replacing at the moment. Now, if you've got a solid state transmitter, and let's just click over, we'll play with the website a bit. I believe I have it right there. So if we go into the thing, we'll look at 10.5 cents a kilowatt hour, which is about the rate here in Georgia at the moment. And if I've got a 84% is the power rate, well, here, let's just pick 86%, which is what an NX10 would be if I already had it. So obviously I'm going to save 0 because that is the rate of an NX10, but turning on MDCL on that 10 kilowatt would average me about $4,500 a year. Okay, now looking at John's question, let's drop it down. I don't think I can go below 8. Let's see. Let's pick an NX3, and we'll drop the power down to 1 kilowatt. Tab that, and let's say we're running a tube transmitter here with, we go 55 again. So on my 1 kilowatt, the MDCL, again, it's about 50%. And so we're talking about $400 a year. The cost of the MDCL upgrade is, obviously it varies from one market to the other, but your payback on this with $400 a year, you'd be well into the 10-year range. You're probably not going to see enough benefit at a kilowatt to make it worth the cost. Now, once you hit the, so if we hit 2.5 with an NX3, at that point, you're starting to look at a noticeable savings. So $1,000 a year, you'd cover the cost of your MDCL up. Well, on an NX, it's built in, but if we had an XR or something like that, you'd see enough savings to make it worth it, I suspect. So again, it varies a lot depending on the algorithm you choose and depending on your specific setup. I mean, whether you use boost or not. The funny thing is, the harder you modulate it with the AMC mode, the more it compresses the carrier. So the harder you modulate, the more the savings. And you'll notice that when I had that graph, I'll see if I can click back to that. And we just scroll back. You notice that we did the tests at 150% mod, and that actually hit the algorithm a lot harder and increased the savings by that much. Now here's something interesting. So what we did, we set the, and I said we did it about 1.3 kilowatts, and the reason we picked that power level was so they could go about to about the 1 millivolt mark and have a low enough signal to actually be able to get field strength measurements. with AMC at 6 dB at the 0.5 millivolt monitoring point, they were still getting a clear signal. So, you know, it is something, and there will be a paper released by that, so I'm not letting you know who or where we were at the time. But keep an eye out for that, and that was really surprising. I expected to see a much bigger impact in the overall coverage area, even though we all know square law for power. That means that, you know, you cut the half or the power in half, you certainly don't cut the range in half by any stretch. So yeah, that was kind of cool. All right, so again, the calculator is on the website. The cool thing is that you can use it for multiple things over and above the MDCL, because you can also use it, for example, just to look at the cost of replacing a tube rig, or if you've got an older solid state rig. Remember that where it says rated efficiency, the third line down, it's talking about overall efficiency, not plate efficiency, not DC. It's AC to RF. So you may, because a lot of the older manufacturers spec plate efficiency, DC efficiency, because that's what you needed for indirect power. So as a result of that, you may need to put a current probe on your three-phase or on your power lines coming in and measure the volts and do the math to calculate the exact AC power consumption. And then you divide that by the output power, the analog or the TPO, and that'll give you the efficiency. 50–55% is a really well-maintained tube transmitter as a rule. So it will vary from one to the other, of course. But that way you can do the math, because there may be that you've got a valid case for just replacing a box and turning an MDCL on, and the power bill will pay for it pretty quick. All right. So that, I think, was the bulk of what I wanted to cover. I see somebody hitting me with the chat window. I probably did something wrong already. Okay, the boss. The boss says I should mention the tube buyback offer. I'm not sure, I wasn't aware it applied to AM, but hey, sales guy learns stuff too. Anyway, if you hit our website or Facebook page, there is a promotion going on where if you are running a tube rig, we will credit you on a new box up to part of the tube. And whoops, there's an oops, it doesn't apply to AM. Boy, that didn't take long. Hey, AM guys, plug your ears, look disappointed, and tell the boss that he really needs to fix that. All right, carrying on, ignoring the boss, because things work better when I just do them. So we looked at the graph. I think we've covered all of the questions. This may be one of our shorter webinars because, to be brutally honest, MDCL has been around for quite a while, and most folks have at least a decent idea how it works. Let's see, so MDCL and 1 kilowatt, I think I got them all. All right, so that is the bulk of it in a nutshell. The things most important to remember more than anything, I'm going to click back and go to the different modes. Like I say, you look at the power savings, but do understand that depending on the mode, it can have an impact on the audio quality. So really make sure that that you're doing listening. And of course, everybody knows when you set up a processor, you don't just listen on one radio and say, okay, that's good, we're golden. So when you do your listening tests, do them on different receivers, because of course some are deaf as a post and some work really well. Do it at different ranges, do it in different environments. Figure out what works for your market. And I mean, you may choose a setting and initially say, oh, I don't like that, and then drive around and say, oh, well, it's not that bad. Ooh, we're saving 40% in the power bill, you know, so, or you may say, no, that won't work for us, but this one saves us 25%, and that's good. So either way, you just go back and look to see specifically what fits your scenario best, and that's what you'll roll with. By all means, we're available to help with any questions at all. Most of our sales guys are pretty well versed in this, and of course we've got 24/7 support. do me a favor, don't call the support guys at 3 a.m. to ask them a question about an MDCL system you don't own yet. They'll get cranky and then they yell at me, and then that just makes everybody unhappy. But certainly, we do have a lot of people who are, so to speak, standing by to take your call. All right, folks, I think that's about all I really wanted to cover. We do have some sources for online information, the Waves newsletter. Ooh, I got to update those addresses. We're running HTTPS now. You can Google them anyway, but if you go to the resources tab, you'll find the webinars. The YouTube channel is pretty much the same. Okay, user Nautel limited. Most of this stuff gets archived and it's easy to find. So by all means, come look it up. And again, any questions at all, feel free to give us a holler. I want to thank you very much for spending the time with me this afternoon. We'll talk to you again soon. Have a great day.